Welcome to Getting the Most for Your HT with Different Antennas, hosted by K3YEE.
I'm Ken, K3YE. My call sign's my first initial and my last name. And I'll tell you that I have a hearing handicap. I can talk very loud, but I'm 20 dB down receding, and I may have to ask for a relay. Okay, I want to talk about improving the signal from your HT, because I'm assuming, since we're addressing new hams primarily tonight, that the first radio you're probably going to buy is an HT. I didn't. I actually bought a 50-watt mobile as my first radio, and this is my second radio.
Ken, why do we call it an HT?
It's a circa 1996 HT, but
What's HT mean?
What does HT mean?
handheld transceiver. Okay? In my opinion, HTs are still basically the same. They all have a rubber duct. They all put out, 5 watts, and something lower, 2.5, 1 watt. Some of them go lower, which the newer ones don't. This one will put out 100 milliwatts. It still works, except the nickel cadmium battery's been upgraded to nickel metal hydride, which is still a long ways from lithium ion, which if you buy one today, it's going to have more capacity, longer life. Okay, I got interested in this because of an article that's could be 10 years old, which is called Getting the Most from Your Handheld Transceiver, HT, okay? And if you Google Getting the Most from Your Handheld Transceiver, you'll find it. I've got the link here if somebody wants to copy it later, but it's much easier to Google some of those words and you'll find it. Well, it refers to a study that was done on the efficiency of a rubber duck. It was actually done, I think, on police transceivers, but presumably the results are similar. And it actually was done by the National Bureau of Standards, probably in Boulder, Colorado, because they have their radio facilities were there, and they probably have the ability to measure RF power and field strength, etc. So what they found was the rubber duck relative to a real quarter wave ground plane antenna was minus 5 dB. That's why a lot of us call them dummy loads. What is minus 5 dB? It means that your 5 watts is really radiating the equivalent of 7/10 of a watt. So it is very inefficient. Why? Because basically it's a loaded quarter wave antenna, but it's hanging out in space. There's no ground plane. There's no virtual other half or real other half of the dipole, and a quarter wave hanging out in space just doesn't radiate very well. So, while the article happens to have 2 other things that are very interesting about losing power, which I'll talk about before I do about gaining power. The one thing they found out you don't want to do is operate it on your belt with the antenna against your body and say, with an earphone. They found that you lose 20 dB. 20 dB is 100 in power. That means you're 1/100th of the 7/10 of a watt that we're already down to. Okay, the other way to not work is operate this inside your metal car. Again, 20 dB down. 1/100th of the power radiated gets out of the car. So if you've ever tried it, you know, HT's inside of cars, unless you've got a convertible, top down, just doesn't work very well. Okay, now let's talk about what can you do to make it better. All right, well, first of all, I need to talk about for a second of how do you tell whether you've made it better. And the only practical way that I know of to tell is to measure using the S meter, which almost all HTs have built in, to measure the signal strength on receiving of a weak signal from a distant repeater, because the S meter becomes nonlinear above S9, and if you have S9 from this repeater, you can't tell because the meter's going to be very nonlinear. So you've got to have a signal which is, say, S3, 4, 5, so that you've got some headspace in order to tell, you know, whether you made it better. Okay, well, the repeater that I use is Bluemont. It's 70 miles away, but it's at 1,600 feet, and it's apparently it's line of sight from my backyard, on my deck. So, receiving with the rubber duck, I have, if I sit it on my wooden deck railing, I receive that repeater S2. If I hold it in my hand, I receive it S5, which proves that your hand.
Can you briefly describe what the S numbers mean for some of the new folks?
Right now, bigger is better. But that proves that your hand capacitively coupling to the radio and your body is an attempt to be the other half of the dipole of the ground. And obviously, if I get S2 this way and I get S5 this way, it's made it better. An S unit on receiving, which there's no way to guarantee that any HT is calibrated correctly, is 6 dB, which means the voltage received at the antenna terminal is a factor of 2 more. So if you somehow get 2 S units higher rating, you somehow have gotten 4 times the higher voltage out from the bottom of the antenna into the radio, which obviously is better. Okay, so how do we make it better? Well, the first thing everybody is told to do is to go get a full quarter wave antenna. Well, okay, I need to say one more thing. So, my reference readings are, don't worry about whether it was S2 sitting on the table or in my hand, because I did all the measurements the same, I think, sitting on the table, on the railing. So I got S2, and what matters is how much increase can I get by changing antennas. Okay, everybody usually is told, go get a full-length quarter wave. And by the way, this is a dual-band HT, as many are, but I'm not really going to talk about 70 centimeter, because most of us are using 2 meters, and problems are at 2 meters. So essentially everything I'm going to say is addressing 2 meters. Well, much to my surprise, I got 0 improvement in the full-length.
You got what?
Versus my rubber duck.
0.
All I'm doing is reporting data. I have no justification for why it isn't better, but on my radio, it is not better.
But it cost you money.
Okay, so this article then recommends that you add a tiger tail. What What is a tiger tail? Tiger tail is a length of wire that you connect to the ground of the antenna, which is a quarter wavelength or about 19¼ inches, which provides the other half of the dipole. And you now have made a vertical dipole. Now, the length is not that critical because when you put your hand on it,
Okay. Just one point of clarity. For the new hams or people interested, a dipole just means literally 2 poles, means you have 2 branches of the antenna. So the rubber duck is 1 branch and the tiger
I'm going to
tail
show a
is the second
dipole
branch.
in a minute.
Right. So,
Anyway, okay. A dipole is 2/4 wave. So now we have a quarter wave and we have the other quarter wave. So this is a vertical dipole now. What happened? I got 3 S units higher signal. 3 S units higher signal by just putting this little piece of wire on. I think that's amazing.
that was while it was sitting on the table.
All the measurements were done the same. You know, it's +3 from,
That's good.
from the reference 0, no matter what zero, because I did change it. It was +3 whether I held it in my hand or whether I put it on the table. I still got +3. Now my only other secret is I recommend that you put a rubber band around this and strap it to the side of the HT. Otherwise, you'll break it off here in the first 5 minutes. But this way, this keeps it as a vertical dipole. Okay. This is the tiger tail that normally lives on my radio. Okay, what else now might you do to make it better? Well, we got to go external now. We got to get out of the radio. So you got to buy a adapter. The one I have is SMA. The radio is female, so this is an SMA male to what is known as a BNC coax connector. You can also get this adapter to SO239, which is looks like this, which is commonly used on ham stuff, but it's a piece of junk. Talk about that later. So get whichever you want, and then you can connect something in the outside world to it. Well, a suggestion is to have a piece of flexible cable, because this connector on radio is not very strong mechanically. And you can buy a cable that has the SMA connector with a foot of small diameter cable and either BNC or SO239 on the other end. I saw them at the Ham Fest, and I actually found them on Amazon. Surprised me. Okay, so now we can get out of the radio to something else. Well, one antenna that you might connect to, this is called a ground plane antenna, which is, I just broke it. It now has 3 radios instead of 4. But this is a quarter wave vertical, and these 3 and 4th virtual wires, which actually are purposely bent down at 45 degrees, make the ground plane. And ordinarily, people build them with this SO239 connector, but mine is built with this BNC connector, and I'll, just because I like them. They're quick connect, they're waterproof, and there are a whole bunch of other reasons why they're better than an SO2 or PL215 or SO239. They're matched for people who understand that. They're real 50-ohm connector. Okay, so now, well, what happens with this? receiving the same signal, I got +4 S units. So you can hang this from the ceiling or something, and as far as I know, you've got to build one of these. I don't know where you can commercially get a ground plane. This is built with flexible wire because you would ordinarily build it with something like 14 solid wire, and it's the worst possible configuration to carry. So I made it flexible.
But that one was free, except for the connector.
Yeah. Okay. So what else might we use? We're talking about a dipole. Well, you could make a real dipole, which is connected. There are two, nominally 19¼ or so pieces of wire on each side of center. One's connected to the center of the coax, the other one to the ground. And repeaters are vertically polarized. So you have to hang this, you have to use this as a vertical dipole for a repeater. Now, the other thing you got to do is you need to run this wire perpendicular at least the same 19 or 20 inches, or else it'll detune the antenna. I'll just mention it. The same thing would work as a horizontal dipole, and if you are on 2 meters single sideband, you would be using horizontal polarization this way. But repeaters are all vertically polarized, so you want it this way. All right, what happened? Halfway vertical dipole, I had +5 S units. It's pretty good. Simple. One thing I'll mention, this happens to have a PL259, which I don't normally use because I can put these on myself. So I think this cable was cut off from something. So I was going to suggest, if you can't make a cable, you can buy a 25-foot one, cut it in half, and you've got, you know, a connector on one end of two 12-foot cables to make something. Because I understand that not everybody can assemble coax connectors. And I'll tell you the story of why I like BMC ones. Is because I was hired as a student when I was in engineering school, and as a student, you basically are a technician. And what do they do with students, and they don't have anything else for them to do? They tell them to build cables. So one of my first assignments was to put connectors like this on cables. Okay, so that one worked pretty darn good. Let's see, I got one or two more. Okay, you can read about something called a J-pole. And if you Google twin lead J-pole, and you'll find, by the way, I'm not telling you all the dimensions and because all J-pole, and you'll find pictures and dimensions of how to build this. This is what used to be TV cable before we had all coax. And what this is well, there are two wires that are in this cable. The reason this thing is called a J-pole is the bottom end of this happens to be connected together, and there's a notch that's cut at a magic distance, which happens to be a 1/4 wavelength up here, and the other wire goes past the 1/4 wavelength and goes another twice as far or half wavelength above that. The coax cable happens to connect to the two wires, and again, a magic distance above the shorted end, which you can find, you know, on the drawings of how to build it. Well, what this ends up being a 1/2 wave, what is called end-fed, because it's energized from just the bottom end. It becomes a half wave vertical antenna. What had happened when I connected this? Again, I had +5. Now, if you don't want to make one, I found out you can buy these. They're called emergency antennas, J-poles, and in fact, there's an MFJ part number, so you can buy one of these, and I found an MFJ for $25. So if you can't build it, you can buy one of these, and the adapter will cost you $4, and you can make it better.
Or find an Elmer and get him to help you with it.
This little roll of wire is actually there for a purpose, and I don't want to get into too technical a discussion, but it makes it better because
It's a current payload.
it actually is a coil of wire. This becomes an inductor, and what it does is it stops the flow of signals that come back down the outside conductor of the coax, which you don't want to happen. So anyway, this little roll of wire is there for a purpose. It's not just to make it easier to store. What's it called? A choke valve?
Choke valve or current valve. Yeah.
But I said, I'm trying not to get into too many technical details tonight, like building these things. All right, I think I go.
It makes the antenna quieter.
Well,
Makes it quieter.
Makes it work, among other things.
supposedly makes it work better.
Yes.
Okay, I got an antenna which I showed just because it's the simplest thing that you could possibly conceive making, except that I don't know why it doesn't work very well. This is a piece of coax, and this is the center conductor, and this is the braid of the coax has been turned back on itself and run down the outside of the plastic shield. And this is a quarter wavelength top and a quarter wavelength of the braid. This is a coaxial antenna. And I don't know why it's got an I got to throw out another term which I'm not going to explain very well, but it's got an SWR of 2 or something, or over 2, which means that not all of the signal is properly going out the antenna. Some of it is getting bounced back, which is not good. And I don't have the equipment, but he has one, and maybe if he wants to demonstrate that, he'll see if he can find out what frequency this works at better than whatever. Well, what did I get with this? I got +3, which is the same as the rubber duck, so might as well use the rubber duck. Okay, got one more thing, which is you might want to just use a mobile antenna. So this is a typical cheap. This one is a Brand X. Happens to be a dual band, meaning it works on both 2 meters and 70 centimeters, and all dual band antennas are going to have some kind of coil in the middle. The one over there that is a straight wire is only 2 meters. This coil it shortens the length of the antenna from the 19 1/4 inches for 2 meters. But on 70 centimeters, the top and the bottom both put out signal. All right, now this is made to go in the top of your car. Well, in order to work properly, it needs to be on a metal surface, and that really needs to be a surface which is a quarter wavelength and radius in all directions, which means people put them on, quote, pizza pans. but you need a 1 meter diameter pizza pan, and most people don't have a 1 meter diameter, preferably steel pizza pan because it's a magnet and it's got a stick.
Family size.
So I'm not sure whether I truly invented it because I haven't researched it, but the ground plane antenna that I showed you only needs 4 radials to work. So why not just use 4 radials? Smack this on here. And aside from the fact that my wires are all bent up from being stored, you now have a real ground for your quote mobile antenna that that makes it work properly. They don't work well at all without a full ground plane. With a 19-inch pizza pan is going to be pretty. It'll work, but not very well. And if you got the one, so anyway.
Are you saying that about this particular quarter wave antenna, or are you saying that about all mobile antennas?
Any magnet, well, all right, you gotta be careful.
Yeah.
Because not all mobile antennas, and I've got a different topic if we have time to talk about mobile antennas. Any quarter wave one's got to have a ground plane. Any 5/8 wave antenna's got to have a ground plane. If the half wave one, which is what the J-pole is, doesn't need a ground plane. And well, let's not talk any more about that right this moment. But anyway, but this type of antenna, which is the simplest mobile antenna, if you want to use it in your house with your HT, it's got to have a ground plane. Now the top of your refrigerator, since they're now 48 inches, whatever, is approaching a reasonable size, except that I don't know what the chances are of there being no cabinet above it so that you can smack your magnet on top of the refrigerator. Anyway, so with this particular mag mount, actually I only got +3, which is the same again as the rubber duck. So the rubber duck really works, great. Some of the others, work better. The ones that had S5. So I think I'm going to quit for a while, let somebody else have the floor.
Which one had the 5 dB gain?
Which one was the 5 dB gain?
Was it the dipole?
Which one had the 5 dB gain?
There were 2 of them. The vertical, the J-pole and the vertical dipole,
Okay.
which actually they're both half-wave antennas, full half-wave antennas.
Okay.
Yeah.
When you said that the rubber duck got 3 dB, 3 S unit gain, that was with the tiger tail, right?
Yes, that's
Okay.
adding the tiger. That's adding the tiger tail
Okay.
to the rubber duck. You gain 3 S units. Now the practical result is good chance that if you need 5 watts in order to be able to hit a repeater, that you'll be able to hit it with 1 watt. And then the big advantage of that is the battery lasts one heck of a lot longer. I live 2 miles about from the main repeater site. As I said, this is my normal radio configuration with the headset. I hit the repeater full quieting at 100 milliwatts and the tiger tail.
Okay.
Thank you for taking time to watch this video. Please visit our Mark Club website for future events of interest.